Hi everyone, welcome to this virtual IoT meetup. I am your host, Frédéric Devien. I'm the program manager for IoT and edge computing at the Eclipse Foundation. I am your host, Frédéric Devien. I'm the program manager for IoT. So our presentation today is from Julien Enoch from AdLink. But before we get there, let me share with you a few things that are happening in the Eclipse IoT community. So first, on May 13, we'll have our Eclipse IoT Day in Santa Clara. This event, you can still register for it. We have a full day of talks with various speakers. I will be there in person. So please register now if you haven't already. Then our IoT developer survey for 2019, we just published the results. So you can access those on the Eclipse IoT website. So please have a look if you want to the full report. And we have a slew of blog posts on the Eclipse website as well, so blogseclipse.org. So you can see Jamaica's little note, my own analysis of the key trends, and analysis by Mike Milinkovic, our executive director. So please have a look as well. Lots of interesting content. But today's focus is really about Julien and his presentation. So Julien, up to you.
Thank you, Frédéric. Hi, hello everyone. So I'm Julien Enoch. I'm a senior technologist at AdLink Technology, which is a Taiwanese company specialized in various hardware for IoT and a lot of other business. So I'm a member of the Advanced Technology Office in AdLink, which is actually the R&D office specialized in both hardware and software. Software from my side for AdLink. So today I will introduce you to the project we started few months ago, last year actually, which is YAKS. And the surname of YAKS we made is yet another key value store. And you can notice there is a question mark actually because we are not so sure it's exactly another key value store as you can have seen so far. So let's go to this introduction, and you will judge if it's actually a usual key value store. So first question is why YAKS? Why we did this new project? So let's take an example, for instance. Home and building management. That's a traditional use case in IoT to have some houses that you need to manage with different sensors or controllers that you want to access remotely. And in other terms, what it means for IoT in software terms, it means that you would like to read, write, and observe data which are specific to your house building. So one common approach to this problem is really to use a cloud and to use a cloud-centric home and building management. And that's a very common solution. So you have all your home pushing data to the cloud, and your application can remotely get data information from your house just connecting to the cloud, and also possibly to publish some configuration to the cloud, and that will be used by your house or your sensor in your house. That's really the common approach. But now, with the emergence of edge computing, what we see is that we would like also to have the data stored not necessarily in the cloud, but also locally in the house for latency reason, for performance reason, possibly sometimes for cost reason, because you don't want to publish all your data to the cloud. Sometimes, in some case, not for consumer use case, but for industrial use case, the bandwidth to the cloud as a cost. And sometimes, though, you want to really have your data living in the edge and getting your data from the edge in a transparent way and in a uniform way. So another step after edge computing is really the fog computing. Sometimes the data itself, they are not necessarily stored in the edge infrastructure itself. The edge infrastructure might be just a server in your house, but might also be, in the case of 5G, some MEC which are not owned by you, but by your 5G provider. And in this case, your data has to be stored sometimes in the things themselves and published by the things themselves. And still, you would like to address those data and to store and access the data from anywhere along the cloud to thing continuum, as this is defined in fog computing. So how to do this? For this we introduce YAKS. So what is YAKS? YAKS is already a distributed service that implements an eventually consistent, scalable, location transparent, high performant, and distributed key value store. And the point is that itself, it's not really a key value store. We have some pluggable backends and frontends that will implement the value store. So YAKS provide a view of a key value store amongst distributed real implementation of key value stores that might be of different implementations, as we will see in the next slides. So YAKS is equipped with dynamic discovery, meaning that you can deploy several YAKS services in your system, and they will discover each other, discover what they have as data stored and what they have as publication and subscription. So how can YAKS solve these issues with a build management system? Well, you can deploy YAKS system everywhere in your house, on your things, in the cloud, of course, and then have a YAKS application remotely connected to the system and getting data in a location transparent way and in a uniform access. So let's see how this works, and especially what is the architecture of YAKS at this stage. So YAKS has a modular architecture relying on different kinds of plugins. First plugin over the engine is a front-end plugin. So that's really for the application to access to a YAKS service. This front-end plugin might be REST for HTTP access or socket. We support TCP at this stage. Later on, we will add more protocols to be used with YAKS and to access the YAKS service. It means that the API actually are remote. So your applications using YAKS is already using a remote API that can be implemented in various languages. So at this stage, we implement only two APIs, which is Python and OCaml. OCaml, why? Because actually the engine of YAKS is developed in OCaml itself. The third API, of course, is the REST API that is also implemented. So you can access YAKS with REST, with HTTP at this stage. On the right side, we have also the backend plugin. So the backend plugin is really the plugins to manage the real key value store or the real storage that are beyond YAKS. So at this stage, we have a memory backend. So it's just a hash map in the memory of the YAKS service. DBMS for SQL database. So we support MariaDB, PostgreSQL, and SQLite 3. And later on, we will add more backend plugins to support more backends like traditional key value stores such as Cassandra, HBase, possibly also just a simple backend such as a file system that might have some interest. On the bottom, you can see there is a specific transport plugin because all the YAKS are exchanging with each other using this protocol that we implemented ourselves, which is named Zeno. I will later on have a quick introduction to Zeno protocol, but that's not the purpose of this presentation. In the future, we foresee also to have, of course, security plugins with authentication and access control, but that's not in place in this first version of YAKS. And we rely on a clock, which at this stage is the system clock, but in the future we might want to plug some external clock, such as a GPS or logical clock. So, typical deployment topology of YAKS in the next slide, which is actually that you have several YAKS service deployed in your system, so that could be really worldwide, in the cloud, in your edge infrastructure, or in the services, in the things themselves. And all those YAKS are connected to Zeno routing infrastructure. So that Zeno routing infrastructure are just software routers that are routing our Zeno protocol. So what are the abstractions that are used by YAKS? That's in the next slide that will come in a moment. So YAKS is a distributed service that helps to define, manage, and operate on key value space. And those the key abstraction at the core of YAKS are the path, the value, the selector, storage, workspace, and admin space. And I will introduce each of those concepts in the next slides. So a YAKS value. What is a YAKS value? It's defined as a tuple, including an encoding and a content. The content in YAKS is serialized as a byte buffer, but we can deserialize it when we know the encoding that is specified. Internally, we have also a timestamp associated with YAKS, and this timestamp allows to provide eventual consistency amongst the different YAKS. So the YAKS path, a path is really inspired for URI, for the path part of URI. So it's a string with a URI format /segment/segment/segment. With the point that a segment cannot contain wildcard characters such as star or star star. And we have here some example of paths. So why not star and star star? It is because those characters are reserved to selector. And what is a selector actually? A selector, in the next slides, a selector is a conjunction of an expression to identify a set of keys and optionally some predicates on the values. So a selector is still inspired from the URI, but we add a query part, the optional query part of the selector. But at first, the segments. The segments are similar to paths, but there they can contain wildcard characters such as star or star star. And this will really allow to do a selection of a set of keys. In the optional part, we have the predicate. The predicate has a form of a field, an operator, and value, and we can have different of those predicates combined with the and sign. And the operator can be as simple as equal, different, lesser than, greater than. So the predicate will be used for content filtering. It means that in the future, when we will implement those predicates, you will be able to do a selection according to some fields of your value that may match a certain part of your predicate. So you can really filter the result of your get. So the properties in parentheses optional also is a semicolon separated list of key values, and we will see in the later slide what the purpose of this. The projection after the sharp key, it's a semicolon separated list of fields that you want to project. What means projection? It means that imagine you have a huge value with hundreds of fields in your value, in a JSON value, for instance. You might not want to get all the value because it might be too big. So with projection, you might be able to select a subpart of your value and get only a subpart of your value, which is as an interest for you. Notice that this is not yet implemented in YAKS, but we foresee to implement this, and it will be implemented in the next months probably. So just a quick slide on selector and path matching. So the star and the star star, you may wonder what we have the two. So the star is ready to match one segment, full or partial. So it means that, for instance, /home/bob/star/light match /home/bob/kitchen/light. And it could be partial because, for instance, in the second example, we have room star that matches room 1 segment. The star is really for a recursion. So it means that you can, with star, you can match several segments and do recursive selection amongst the paths of your keys. So the next concept is a YAKS storage. YAKS storage is defined by the mean of a selector. So it means that you define a storage to store really a set of keys and a backend, because the backend are the factory of storages. It means that you can define a storage, for instance, in a memory backend or in a SQL backend, or in the future in a HBase backend. And the storage will be in charge to store all path value for which its selector matches the published path. The workspace. So workspace in YAKS is specified with a given path. So it's a single path, and it allows to operate on path value for which the path is a prefix of the path. It means that really it's just a tool to use relative path instead of always using absolute path. And later on, we might also be able to implement access control depending of the workspace you specify to forbid you to get outside the workspace. But notice that still you can you can use absolute path using the workspace. In YAKS, we also implemented what we called an admin space. So it's really an administration space allowing you to monitor and to control key components of YAKS services. So you can see here the full hierarchy of the entities that are deployed in a YAKS service. And of course, as all YAKS are connected together, you can remotely control all your YAKS services. We'll see an example of this in the live demo just after. So the operations that are supported by YAKS on the key value space. So of course, we have the regular key value space operation, which are put, update, remove, and get. Put, you put full data. Update, that's possibly quite new. It's really, we foresee to be able to patch a data, avoiding to send the full data again, but just to update it. For instance, in a JSON value, you might want to just modify one field in your JSON value, not resending the full JSON value itself. So you really want to update it. And of course, you want to remove the value and to get the value. In addition of this, we also support pub sub mode with subscription and up subscription. It means that you can subscribe to publications and really register a callback that will be called for your publications. And in addition of this, we also implement what we named EVAL. So EVAL is really you register a computation function, and you can later on have other applications triggering this computation function remotely, and your computation function will return a value. So we'll see an example of this in a few slides. So already YAKS is able to support 3 different models of data exchange and publication. The first one is a query model. Your data are published via put and update. You have storages that are matching the publications. They receive and store the data. And later on, you can query the data via the get operation. That's really an asynchronous model of retrieval of data. The other model is pub sub. That's a traditional model used in distributed system. So here, there is no need of storage actually, because the data which are published by application via put and update are routed automatically by YAKS infrastructure to the matching subscribers. So notice that, as I said, you don't need a storage for this. It means that if you have no storage, but you can also combine subscription and storages. It means that if you publish a data and there is a matching storage, the storage will get it. And if you have a subscription, the subscriber will also get the data. And then the third model is RPC, remote procedure call model. So you can have your application registering a computation function. Notice that when we said registering the computation function, it doesn't mean that the code of the function itself will go inside YAKS. It's just meaning that you're registering the fact that your application is able to execute a function that is called remotely. But still, it will be your application that will execute the code of the functions. Still, other applications can remotely call this function via YAKS using the eval function. So we think that this model might be useful, for instance, to implement microservices or parallelism, or possibly also MapReduce mechanism. So now let's start with have a look to the API of YAKS and with the Python API at first. So the slide pop up here. What is the main class of YAKS? At first, you have a static method, which is a login method. So in this method, you pass a locator, which will be the IP and the port number of your YAKS, remote YAKS service. And well, this by default, this will use a TCP connection to YAKS. And then you can log out, of course, and you can also create a workspace using a pass. So it means all relative paths will use this pass as prefix, and you can get the admin space. What you get in the workspace interface? Well, you get all the operations that I just described a few slides ago, starting with a put on a pass on a value, update on a pass on a value, remove on a pass, and you can get using a selector. You can subscribe using a selector on a listener callback. So that's your callback that you're registering as a subscriber. And you can unsubscribe, of course. You can register your eval. So here you see you register using a pass. So that will be the path where your evaluation function will be accessible remotely. And the callback is your function that you register to be called remotely. And later on, you can unregister this eval. If you want to call a remote eval function, you can use the eval function here that use a selector, actually, because we foresee that you can trigger different functions at the same time and fetch back the results as a list. So an example of usage. So from YAKS, you can, of course, you need to import everything. You log in to a YAKS. Here, I log into a local YAKS. I create a workspace on /demo/ac, meaning that, for instance, the next put, uno, will go to /demo/ac/uno because it's a relative path. So you can see the second one is actually equivalent, second put is actually equivalent to the first put. The third put, you see, is using a path which is outside the workspace. Well, that's allowed with YAKS by the infrastructure, but when we will implement access control, that might be forbidden by access control. And then you can do get /demo/star, for instance, to retrieve all the values that are stored with keys starting prefixed with /demo. You can register a subscriber. You define the callback and you register it, and you want it to subscribe to all publications that are matching /demo/oh/star. And when you do this put, well, your callback will be triggered. The eval function, well, so eval function you can register here. So you can see that you can define parameters in your eval functions. And what it means, how those parameters are used, they are used actually by the properties in the selector URL that I described before. So in parentheses here, you pass you give the values that you want to pass to your evaluation. So this hello, this world value will be passed to the eval callback. So now a quick look on the admin interface. So on the admin interface, you have a view on all the entities stored by YAKS. So you can get front ends, you can list all the front ends. You can, in the future, it's not yet implemented, but we foresee to have a dynamic loading and removing of backends and front ends. So you have the function to add a front end, to remove front ends, to add backends, to remove backends. What is implemented actually is dynamic addition of storage. So you can add dynamically a storage and remove dynamically storages. And you can list what are the current sessions and the current subscriptions. So what is used, what are the clients which are using your YAKS service. So here we have a quick example of storage creation in YAKS. So again, we log into YAKS, we get the admin interface, and we can add a storage, giving it a name, some properties, the main property being the selector that we want to use, and possibly selecting the backend ID, so the backend that we want the storage to be created on. So here, memory storage, and later on, a SQL storage or a memory storage. So now a quick view on the REST API. Well, actually, we made this quite simple. We really mapped the YAKS operation on the existing HTTP methods. So you can really do a put in YAKS on a path and a value using the put HTTP method on the URL. So the host being your YAKS service with the appropriate port for the REST API. And you just use the path that you want to put. And the HTTP body shall contain the value that you want to put for the path. The update will use the patch HTTP method. The remove will use the delete, but no HTTP body. And the get will use a similar path with a selector. And it's a regular get HTTP method. The eval is similar to a get, but to distinguish for the get operation, we set a header which is es.yaks.eval. Here we have a few examples of usage with curl, and you will see during the demo that you can interact actually with YAKS service, running YAKS service using curl. If you have a shell on your host, prepare it you can prepare to do some curl operations for the live demo. So here we have, for instance, a put operation on a YAKS service on localhost. Still, remember that you address the localhost, but the put might go in a remote storage in another YAKS instance, depending where the storage matching /demo/eu/test is deployed. And same for the get. When you do a get on /demo ***, it might call the YAKS system to get the data from different storages. So we have example of delete and eval here. So now we can switch to the demo. So here is a view of the demo that is currently running. So we are using 4 Linode instances on different regions in the world. One in the US West Coast, one in US East Coast, one in Europe Central in London, and one in Asia in Singapore. So you have the domain name of those instances. I will run one on my local host here. All of those instances of YAKS on Linode are already defining a storage, those storage actually in memory storage, and you can do some put and get here. So let's move to the example. So just the time the video switched to my demo desktop. Here it is. So you can see I have 3 terminals here. In the first one here, I'm starting YAKS and Zeno locally, and they will connect to the instance in London here in Europe Central. In the bottom left corner, where I have a small HTML page, which is a tool we developed in JavaScript, and that leverage actually the REST API from YAKS. And if I refresh the page here, you can see in a few moments that actually, yes, we have a view here of our current YAKS system. So let me switch this to full screen so you can better see. So what are the square in the middle? That's really the Zeno broker instance themselves. The blue ellipse are the YAKS services, and you can see in the right page the JSON part that is get directly from the YAKS. And you can see here that we have already deployed storages that are defined as the green cylinders. On the bottom, there is one Eclipse without storage. That's my current YAKS service running on my laptop. So let's move back here. So actually, I can show you here how this tool is actually working. So in the terminal here in the bottom right corner, I already predefined some batch operation, which are actually just quick shortcut to curl commands. So just to let you see this, for instance, I can do a get, which is actually just a curl get. There is the eval function defined or the put function defined. All of these are curl commands. So just move this here. So if I do a get on /@/star, for instance, you can see here that I get five different results, which are actually the 5 instances of my YAKS. The one in local and the one in remote. I can also see what are the running storages. So if I do a get on /@/star/storage /star, for instance, I get only the result for the storages. So I get 4 storages, which are the 4 storages running in the Linode host, but not yet my my own storage that I need to declare in my local application. So let's do this in Python. In the middle terminal here, I'm starting a Python terminal, and I will at first. Sorry about this. I just need here at first to do some imports, those ones. So import everything from YAKS, and now I can connect to my YAKS here, my local YAKS. I can create a workspace on /demo, for instance, and to create a storage, I need to get access to my storage here using the admin interface. So I will create a set of property for my storage. So I define the property selector on /demo/julien/storage. And now I can add my storage locally here. So if I refresh the page here, you can see that the storage appeared in the control view. And if I do a get, again, a get on storage ***, now I get my local storage here on my local YAKS. So now we can do some put and get, for instance. So if I do a put, for instance, on /demo, I will do a put in let's say Asia Pacific storage. So I do a put here in Asia Pacific. This should go through my local YAKS to the Asia Pacific storage, and later on I can retrieve my data even for the local here with a get, and here it is. In my Python script here, now I can also define an observer. So let's define the callback here. So here I define an observer function, and that I register now with a subscribe. So now I can encourage you, if you want, to do some puts if you want, using the curl command that is displayed here. You can do some puts on slash demo slash whatever storage you want, or no storage at all, actually. All it needs is to start with slash demo, because as you see, my subscribe here is using ** prefixed by the path of my workspace, which is slash demo. It means that I created a subscriber on slash demo slash **. So every publication made on slash demo slash something should go to my subscriber. So let's, for instance, do one here for my local. If I do a put on this stage, I will do a put on, for instance, on US East Coast. I do a test. Here you see, so the value should have been stored in the storage on YAKS on US East Coast, but also have been received on my laptop as I subscribe to all publication made on demo something. So just to show you the curl command, so I can perfectly also do a curl command on a remote YAKS. So here I do, for instance, a get from Asia Pacific REST API. So here you see I contact the YAKS on Asia Pacific in Singapore, and I ask him to get everything from demo ***. So it means that I misspell in the name, Southeast. So here you see the result of the command. I get two values. The one from which is stored in the YAKS on the US East Coast, and one which is stored in Asia Pacific. If I do a put here, a local put in my on my own storage in Julien, for instance, so I do an put on slash demo slash Julien slash test3. And I do the same get again from Asia Pacific. I also get it as a result. It means that the YAKS in Asia Pacific has contacted the YAKS in Europe, which contacted the YAKS on my laptop to get the data. So already we have YAKS implementing a crawling of the data and be able to get data from different storage all among the system. Quick example with EVAL, for instance. Here, I'm registering eval operation. So I'm defining an eval operation, which is a classical hello world. As you can see, I define by default the name value as world, but it can be replaced by the caller with any values they want. So now I register this. And I can do now an eval on my function on slash demo slash hello. So that's the name of where I registered my function, for instance. And when I do this, I get hello world. If I want to change the name, I just need to specify this name as a parameter in the selector path. So in selector query part. So here name hello Julien. And I get it. But you can see the curl command is here. We just specified it's just a regular get using curl, but with a specific header. So as you can see, I can also do the same, contacting the instance, for instance, this time in US East Coast, for instance. So US East.yaks.is/demo/hello. Number. And here, yes, contacting the East Coast part, it's my eval has been triggered locally. So eval function also supports selectors, meaning that I can do an eval on /demo/star. And as you can see here, I also get the same result. If there are several evaluation functions registered with matching with paths that are matching my selector, I will get the list of the results from the different eval functions. So I didn't saw any remote publications, so I guess nobody tried yet, but you can try this later. So I will go back to my slide for a quick wrap up. So in a conclusion, what we saw from YAKS is what we foresee to implement is really a distributed service that implements eventually consistent, scalable, location transparent, high performance, we hope so, and distributed key value store with pluggable backend and frontend. So YAKS will really allow you to provide a uniform abstractions on the scalable infrastructure to integrate heterogeneous storage that can be distributed amongst a very large scale system. And YAKS actually is already used in an Eclipse IoT project, in the FOG05 IoT project, Eclipse IoT project. As you can see, the architecture here that has been presented in the past in FOG05 slides. Really, the FOG05 agents are leveraging YAKS to implement everything that they need to implement their communication between all the agents. And of course, yes, the Zeno protocol underneath that we will probably present in a future meetup, Eclipse meetup, we hope so. So YAKS is not yet fully open source. We foresee to open source YAKS in the future, probably this year. Probably in Eclipse, because actually FOG05 is already an Eclipse IoT project. Still, you can try it. The APIs are open source and available on GitHub. The Python API, the OCaml API. It's also available through Pipe3. You can just install the YAKS API with Pipe3 install YAKS. And we will keep our online YAKS service, which are interconnected. So the one I just used for the demo, we will keep those alive. And so you can try, you can watch again what I did with my commands, and you can have some try of the services live in the future. Of course, you can get back to us either via email, via Twitter, or if you have some issues, just post issues in the YAKS API GitHub. Thank you and for your attention. And now, if you have any question, I'm free to listen.
Yep. So questions are typically me reading them from the chat, and I think, roughly speaking, you answered the first one by Anderson Silva, who was asking if YAKS is open source. So from what I understand, not yet. I mean, some of the clients are already open source, but the core is not, and you will be working with us at Eclipse to bring that as a new project. So I'm excited.
Exactly. Yes, we need to discuss with we have some partners already in this project. We need to discuss and to coordinate and make this open source very soon this year. Yeah.
All right. Now, one thing I wanted to ask you. So obviously, the market for key value store solutions is crowded. I mean, you think about Zookeeper, etcd, whatever. What makes YAKS different from those solutions in your perspective?
In my perspective, it is not really similar to those solutions. Those solutions are already implementation of key value store. YAKS itself doesn't implement a key value store. It provides a key value store view amongst whatever key value store you would like to plug in YAKS. And moreover, it allows you to access those key value store in a uniform way, in a location transparent way, wherever they are deployed in a system.
Okay, and then suppose I wanted to deploy it tomorrow morning. Suppose it was already open source, that kind of stuff. So, what would be the typical engine that you would recommend for me to use underneath YAKS?
Well, at this stage, we only support memory and SQL backends, but in the future, it will really depend your system on where you want to deploy the storages, of course. Because if you want to deploy a storage, for instance, in a small device, let's say on a Raspberry Pi, you probably won't be able to deploy HBase or Cassandra on it, and it will be rather preferable to deploy, for instance, a simple SQLite 3 database, or even just a file system. For instance, we might foresee use cases where you want to remotely access some files on a remote things. Yes, you can. We foresee that we will implement a file system backend, so you can get content of your files just through REST or through Python remotely from wherever you are connected in the YAKS system. So we think that it will already depend on the use cases. For instance, also we implement a memory backend just to store the key value in memory, in HashMap, or in a better technology, in the memory technology in the future. Because sometimes you don't want to store on disk, you just want to have a working space in memory, and this working space going out as soon as your YAKS service go offline, for instance. So okay. I think it will really depend on the use cases.
All right. And now one last question on that team. So essentially, your presentation was about YAKS itself, but in the title you were really saying it's a key value store for IoT. So what makes YAKS a good solution for IoT deployments and scenarios?
So I think one first answer is really the size itself. So just a minute, I'm starting here and sharing my monitor on my YAKS, so it might be too small to see. Hold on just a minute that it pops up, but you can see here that the YAKS daemon itself is only 20 megabytes of runtime in memory. Mm-hmm. And if you add the Zeno broker here, the Zeno broker is 10 megabytes. But again, the Zeno broker might be on a remote host in a different host than the one running YAKS. So YAKS is really tiny, so it might fit on lots of different hardware, tiny hardware. And that's why we think it's suitable for IoT. And moreover, as you can see, the protocols that we have underneath Zeno, that we will probably present later this year, is also suitable for IoT because it's really tiny. It's a tiny protocol that is suitable for various transports underneath, leveraging different techniques to support low bandwidth, very low bandwidth, very small MTU, such as Bluetooth, for instance. Zeno is running on Bluetooth. So we really foresee that YAKS, thanks to Zeno, will be able to adapt to various IoT deployments at scale. Because again, as you can see in this worldwide demo I just made, we are able to deploy a YAKS system at a worldwide scale, and we hope to have more tests with tens or hundreds or thousands of different YAKS instances on Zeno browser to demonstrate large scale of system.
All right. Okay, now going back to the questions in the chat. So, by the way, if you are still attending and you have additional questions, please put them in the chat and I will make sure that we try to answer them before the end of this broadcast. But for the time being, we have a question for Alex Kiritkos asking, when you subscribe with a selector, where is that selector executed? On the YAKS server or on the YAKS client?
So the selector actually is just really a subscription. There is no real execution of the selector. It's just that the application declares in YAKS that it is interested in all publication matching the selector. So it means this subscription will be propagated amongst the YAKS service and actually in the Zeno brokers themselves. And the Zeno broker will be in charge to route all the publication matching the subscriptions made by YAKS. So the subscription really will be stored in the routing table of Zeno and will allow Zeno to route the appropriate data at the appropriate place. Meaning that a publication, if you have a publication, for instance, in your applications that doesn't match any subscription or any storage, actually this publication won't go anywhere. It will be dropped locally by your YAKS application. It will be routed only if somewhere in the system there is a subscription or a storage.
All right, that makes sense. Thank you. Another question from Deepak Sood. I hope I pronounce your name right, Deepak. Sorry if that's not the case, but what's the difference between Cloud Spanner, Firebase real-time database, and YAKS?
Oh, I'm afraid I'm not sure. I don't know this one. Can you repeat the name, please?
Cloud Spanner, and then Firebase real-time database.
Okay, so my guess is that those ones are key value stores that are already implemented. Well, it's again, YAKS itself is not per se a key value store. It can be viewed as a key value store, but it's implemented on the top of existing key value store. So it's rather a way to access different key value stores. So in the future, yes, we can add backends to support a spanner deployment, for instance, or any other key value store that are deployed in your systems.
Yeah, okay, that makes sense. All right, I think that's the end of the questions we have in the chat. So, well, if you have any last-minute question, please add it right away. If not, well, thank you so much, Julien, for sharing this with us. I'm looking forward to, well, at some point, welcome YAKS as a part of the Eclipse family. One thing that I didn't quite grasp was the relationship between Fogo5 and YAKS. So is Fogo5 already leveraging YAKS in some form at this point?
In latest version, yes. In latest version, the Fogo5 agents are using YAKS, and actually they are using YAKS with a certain pattern, which is desired state and actual state. So the YAKS agents are defining two kinds of storage: the desired state and the actual state, meaning that they are publishing their real state in the actual state storage and are listening to commands coming in the desired state. So one wanting to drive an agent will do a YAKS publication in the desired state of the agent. This agent will get it, try to apply the change, and reflect the change in the actual state if succeed. So that's the way Fogo5 is leveraging YAKS in the latest version.
Okay, and that means, I mean, what kind of actual data store is Fog05 using underneath YAKS for the time being?
For this stage, it's memory and SQLite 3, I think.
Okay, so those would be the most mature implementations, so to speak.
Yeah.
All right, that makes sense. Okay, I don't see any more questions in the chat, so I guess that's all for now. So thank you so much, Julien, once again for this good presentation. Thank you all for attending, and thank you to Jamika, our angel behind the scenes, who's been playing cameraman and organizing this meetup. So I'm looking forward to see you all 2 weeks from now for our next virtual IoT meetup. And in the meantime, do not hesitate to reach out through the meetup site or through Twitter. So I'm there as a Blueberry Coder. You can find me there. And yeah, see you next time. And thank you all once again.
Thank you. Goodbye.